Okay, I'm not sure what happened there, but here's number 5. You've got a 0 at -2, which means that x plus 2 is a factor. A 0 at -1, I'm sorry, 0 at 1, so x minus 1 is a factor, and here x minus 6 is a factor. Now, -2 and +6, the polynomial passes through that point. So that means those occur an odd amount of times. And at +1, it is tangent to it. So that occurs an even amount of times. So x minus 1 as a factor could be to the 2nd power, or to the 4th power, or to the 6th power. It just has to be an even amount of times. In fact, it actually behaves like the parent function. So this looks right here, this looks kind of like a parabola, and so that is squared. Right here, this looks like a line, so that's probably to the 1st power. Here, this looks like a cubic function, so we're looking at something to the 3rd power, and that brings us to letter D. Oh, recovered. Can't believe it. All right, number 6. Who doesn't like green? State the degree. So this term makes it 2x to the 5th, but when I multiply it by that, I get 2x to the 6th. And then I know I get minus 18x to the 5th, but I'm just concerned about the greatest degree. And then x plus 1 squared, well, that ends up having x squared as its leading term. And when I multiply these two leading terms, I get 2x to the 8th power. So if I were to expand that entire thing, I would have a polynomial that begins with 2x to the 8th power, and then some terms after that. So that tells me the degree is 8. That means that there are at most 8 x-intercepts. Well, 5 of those x-intercepts are just repeated when x is 0. 1 of those x-intercepts is when x is 9. Any x value that makes the results 0. And 2 of those x-intercepts are the same at -1. Intermediate value theorem. If you find f of 1 equals 3 minus 5 minus 2, which is -4, and f of 8 equals 1,494. So the intermediate value theorem is saying that, first of all, polynomials are continuous. That means you can draw the whole thing without lifting up your pencil. And when x is 1, the y value is at -4. When x is 8, the y value is positive 1,494. So the only way to get from a negative number to a positive number, at some point, at some x value, y had to have been 0, which means that x value is a 0. So that is the intermediate value theorem. Like lots of x values are producing different y values. When x is 1, the y value is negative. When x is 8, the y value is positive. So somewhere between -4 and 1,494, the y value must have been 0 at least once. And so when the y is 0, then you have a 0. X is 0. No, sorry, the x is called a 0. Use long division. And I'm gonna go back to this one because I don't like the way I explain this thing. So when x is 1, I'm at -4. What's -4? When x is 8, You're at 1,494. Okay. Now, these two ordered pairs are on that polynomial f. And f is continuous. There's no way to get from that ordered pair to that ordered pair without crossing this line. And as soon as you cross that line, the y value is 0, which means you have a 0. So let's pretend, I don't know what this looks like. Let's say it looks something like this. Well, right there is an x-intercept. That is a 0. So the intermediate value theorem is guaranteeing that you're going to hit all the y values between 1,494 to -4. Here, I want to find a number that cancels out 6x cubed, and that is going to be 3x squared. So 3x squared times 2x is 6x cubed minus 9x squared. You subtract, these go away. 6 minus -9 is positive 15. Drop down the 14. Now you need a number that cancels out the 15, and unfortunately it's going to be 7.5. So 7.5 times 2 is 15x squared, and then minus 22.5. These cancel out. 14 minus a negative 22.5 is 36.5x. Drop down the -6. And then you need to cancel out the 36.5, which means you need 18.25. 18.25 times 2 is 36.5. 18.25 times 3 is that. These cancel out. -6 minus -54 gives me this 48.75. So the final answer is 3x squared plus this plus the remainder over the divisor. Last page. Use synthetic division to divide. So 3 goes in there. Now 3 for x to the 4th, 0 for x to the 3rd, -2 for x to the 2nd, 4 for x to the 1st, and then 0 for the y-intercept. And then we do synthetic division. We begin by dropping that down. So the answer is 3x to the 3rd plus 9x squared plus 25x plus 79 plus the remainder over the divisor. Last, find all the zeros, knowing that 2 is a 0. So if 2 goes into the window of my synthetic division, then I should get 0 in the end. I should have a remainder of 0. And I do. So this just verifies that 2 is a 0. And what am I left with? X squared plus 4x plus 3. Well, that factors into x plus 3 times x plus 1. So my last two zeros are -3 and -1. They told me that +2 was a solution in the script. So I found all 3 zeros.